revolves like a weathercock to give the wind direction. This, by so doing, he was trying to demonstrate that I have understood everything. So, this, by damming a artificial rivulet, he created Sukna Lake in Chandigarh. This was aimed at ameliorating the microclimate of Chandigarh. As I said in the previous discussion, that Chandigarh is the only and only city which has 50% green spaces. We have 1900 parks in the city. 1900. During one of the discussions in Singapore, one of their ministers was arguing with us. He said, we got 250 parks in my country. He said, what we are talking, my own city got 1900 parks. So you look at the green spaces. And this is one of the biggest Asian garden, rose garden. And now coming to the architecture of Corbusier, in this High-Court building, he experimented with double roof. He introduced the system of louvers to shape the buildings. The right orientation was used, and the same thing he did in the second area on the top right. And just like Nobel said, he used small water bodies to improve the microclimate of the capital project. This was a demonstration project which is called the Tower of Shadows in Chandigarh. Tower of Shadows is to indicate, how climate acts on the building, and he put no louvers on the northern side, and there are different kinds of louvers on other three sides. This was a demonstration project to tell architects and other students that this is the model I am making, you can just replicate it as it is. And this is the city museum, again we used double roof here. So what I am trying to say is that Corbusier gave a lot of importance to the climate. Then the similar thing that happened before Corbusier when European study was being built. The Harvard Baker and other eminent architects used they all were working on the capital complex of New Delhi. And if you see the pictures of New Delhi, Rashtrapati Bhavan and others, you see very small windows, thick walls and projections and everything. And in the middle of the 90s, when Korea designed this building, he used glass very sensibly, only putting it on the northern side. But this is the kind of architecture we are producing now. It is totally disastrous, and this is the building I am talking about, that the report of Indore currently says that people will have serious ailments in a very, very near future. You see, there is no ventilation, thousands of people working inside, all projects, all dirty, and no pressure coming and being recirculated in an air-conditioned atmosphere. So, this is the kind of architecture we are doing these days. So, there are many such examples. You see on the left photographs, it's put down in Mohali. The architect designed a very, very nice building. And the bureaucrat, the senior bureaucrat, post-architect put glass all around, and the building was almost completed. So, the whole elevations were changed, and the glass was wrapped around the whole building. It's a huge building. And in the month of June, if you go there, whatever the amount of air conditioning, it never cools. It works like a furnace. And you know that has given directions that I don't know how you do it as a bomb. So this is the kind of architecture we are doing now. And these are the buildings we are making now, irrespective of any climatic considerations. And now coming to, we all know that India is divided into different zones climatically, and each zone has different design parameters, the design strategies, And in the composite climatic zone, I happen to work in a composite climatic zone. And these are the strategies being adopted in a composite region. We say that we have to resist heat gain in summer and resist heat loss in winter. And we have to promote heat loss in summer and we have to promote heat loss in monsoon. How we can do it? It is mentioned on the slide. You can have a quick look. And we happened to design this church many years back. And in this church, you can see very, very small openings, minimum use of glass. And we have also put cavity wall. And the color of the top glass wall is also painted white, so that it reflects the incident sun rays. And you can see the cavity wall here. And you can see small openings and deeply recessed openings. Lighting is 100% natural, no artificial lighting is used. And this building was selected by Day in publication in some of their books. And this project was published at 5 many places. Another project is a school I did in Mumbai. It is a junior school. Can somebody imagine that a junior school building looks like this? I will tell you the reason why. This school is owned by Captain Amrinder Singh, and you all know that he belongs to a royal family, and his mother, the queen, was a jury chief, and there was a competition, and the lady said, the work will be given to that architect who will not cut even a single tree. So there was a large number of trees, and we designed the building in such a manner. Otherwise, with the junior school, we would have separated, other architects have separated all around with the very fancy good forms and everything, playful and all that. But I designed a very compact building in order to save the trees. You can see a new building, but all trees are in reality. Then next one is that you can see the cross section and you can see the right photograph. The corridor is going in the middle and it has cutouts on the either side. It insulates the classroom from the noise also, plus it facilitates ventilation. This is the church designed in Chandigarh. It has gone for some international exhibition also. And in this church, you can see either the windows are not visible or they are very deeply recessed or shaded. Small windows and they are 100% natural light. No artificial lighting is used there. And this is a school I did in it's an extension of a school in Patiala. The greenish blue color structure is the existing one, and I added a C-shaped block to it because the site was very tight, there was no scope to expand it in any other direction. So I put a gap in between two buildings so that foundations will not clash, and this gap acts as a mid shaft, and it has worked very well. This is a school, you can see it normal looking, but climatically very responsive. You can see the cutouts in this section, and you can see the sections on the bridges connecting with the loop block having cutouts in between. And the top roof is put in such a manner that it facilitates air movement and no rain can enter interiors. And this is another school we did in Chandigarh, and this is a Christian school. You can again notice that all windows are fully protected. And this is a model. This is the only school I think there are very few schools these days, new schools which have courtyard planning. So we introduced courtyard planning. Then there was a competition organized by HATCO, and the jury chief was the famous architect Anand Raje. And we participated for an ideas competition, for laying down some guidelines for composite cladding, housing guidelines for designing buildings in composite cladding. So we designed this block. You can see we provided the earth bounds. You can see perforations in the parapet, and the middle staircase is located very strategically, because this staircase has vents at the top, and we facilitate here movement such the object from the dining room and the visitors at the top. This is the reason why we got award from HUDCO. The master plan had again courtyard planning, and this is the section showing air movement in this housing. The church, another Lady Padma Church at Kerala. You can see how I have treated the windows with the brick embrasures. You can see in plan number 3 is written. You see small windows, and they are further filled with circular wall. And this is how it looks. And you get the skylight also from the top. And recently I did a library in a very remote village in a Moga district of Punjab. And this is the library. This is such a remote area that it is impossible to even execute the drawings there because the contractors are available, but nobody in the village can understand the drawing. So constructing such a building there is a big challenge. So what they did is they designed this library and put these windows above the rack height, and racks are placed along the walls. And those racks are, working as insulators. And there is a system installed on the top. Which cools the air, and the cool air is thrust down to the racks. There are ducts on both sides, and the orientation is 100% correct. And there is a gravity wall on east and west, and louvers on this deep thrust windows on the north and the south, and there is a ventilation system at the top. And I feel proud in saying that we do not have any fans there, and we do not have any air conditioning, and it works. And next is the hot and dry region. That's another category of climate, broad categorization of climate in India. This is the region of Rajasthan and Gujarat, and these are the design categories for designing buildings in this region. I will go with fast. This is urban housing. It is council, and we oriented most of the buildings north-south. And the road wall on the top side, where the grade structures are there, the army general was posting me that you have to face the longer side towards the main road so that the buildings are visible. I said that the 100% wrong orientation, sir, it will ruin everything. So it's the entire organization. So I have to get 16 presentations in the army party to convince them it's the right way. So it brought for the great 1 year, but I have waited long and it works. And this is this how it looks. We use light colors again, deep recessed windows, and each single tree which was there on the side was again. No tree was cut. And the third category is warm and humid. We designed several hostels and youth hostels in Bardwan, Joshipur, and Guwahati. We all, in a simple language, we all understand we need more ventilation in a humid climate. Though there is a number of guidelines for designing buildings in a humid area. This is the hostel I built in Bardwan. Bardwan is again such a place where I was finding it very difficult to have training lessons and training from writers. And where number 4 is written. You see, this is a dormitory, and this dormitory got 6 openings. If you open all the 6 windows, you don't understand that. And the construction was very simple. It can be easily executed in a remote area, and this is how it looks. The pipe structure in such public buildings, so I opted for water spouts, and then this concrete challenge by the roofs. We have more vaccination in the lobby area. And this is another blue coastal in Odisha in the same region. We have forecast planning and deep process openings and projections and light colors. Then there is a small zone, moderate zone near Bangalore. I never get any building there. These are the guidelines of designing buildings in moderate region. And then the core region. In core region, which is Kashmir basically and parts of Himachal Pradesh, they say the guideline says that we have to resist heat loss and we have to promote heat gain. And then another problem is accumulation of snow on the rooftop. I was told by your lesson there that if you paper your roof at 23 degrees, the snow will never accumulate and it will get automatically cleared. So I thought that that's not the clear, then I said okay for the annual 23 degrees without any consideration. So, and for the annual 23 degree of this sloping roof, and no manual cleaning of snow is required, no mechanical cleaning is required, and management comes on its own. This is the plan. Then, there are certain technologies which are available now. This is the when we put the solar panels on the rooftop and we can take it to the optic cable. No batteries are used. Normally batteries are needed for the thing. And now we have solar trees, we have wind trees, we have green elevators. What is going on in this direction? And this is the picture of Varanasi. The plastic is being used by the road construction. Very good example. And this man from US is advocating urban farming. He says buildings can have agriculture also on that. And this is a building in Bahrain which have huge windmills inside into the design. And these windmills can create almost the rate 15% of the total energy consumed by this building. I was talking about the wind trees. And the conclusion of the whole discussion is we should design buildings according to the climate. We should not follow Western models. And thank you very much.
And I will take some questions from you now. Yeah. Any questions? No? In that case, I have a question now. This temperature dialogue has it influenced in Europe and what is it the positive influence?
I think bylaws have a lot of flexibility as well. It is normally projected that bylaws are very restrictive. It's not like that. We usually created these churches with circular forms and different forms. It is permissible within the law. And bylaws are made, okay, this much setback, this much covered area. Even career bylaws are mentioning that you need to have 10% floor area for the window opening. These are basically thumb rules to give the ample amount of natural light inside. So if we simply follow that, and it works.
At the end of the day, the users will have
Yes.
Thank you, sir. So I think now we can go for our presentations. First is it? No. The topics presented in this session are flow flow analysis for natural navigation to adopt mixed mode. Case of office buildings of Ahmedabad presented by US Petroleum
He has captured the column line before I came here.
Good afternoon, everybody. My topic is flow-based analysis for natural ventilation to adopt mixed mode. And we have taken the case of office buildings in Ahmedabad. So first of all, I'll go through what are the other contexts. So I'll be introducing the topic and then the keywords that we focus on the presentation and the paper, and then I'll be taking you through the topic with the methodology, the case studies, and parameters for simulations that we selected, and then the analysis and observation that we draw, and then the conclusion and the further research aspects. So, for the introduction, I would like to first talk about the global trends. So, like we know that we are seeing the world is seeing an exponential rise in the population, which is resulting in rapid urbanization, and that is ultimately leading us to the high energy consumption. You can see, as you can see, this graph is world map is showing the different electricity consumption scenarios in different regions of the world. And if you see in the South Asian region, in which India plays a major role, from 2005 to 2015, there is a projected increase of approximately around 1.5% hike in energy consumption. Now, we chose the commercial sector specifically because of these points that in Indian commercial sector, energy consumption grew by 60% in just 15 years from 1990 to 2005. There is a clear 8.62% increment in Indian annual energy consumption, out of which 11 to 12% increment in energy consumption could be seen every year by commercial sector only. If you look at this graph, you can see in India that you can see the comparative growth of commercial and residential sectors consuming electricity. And the commercial sector itself is increasing 4 times in the given time period. And as per the census 2011 and as per the Ministry of Finance
I
Economy,
have a quick suggestion for you. If you can come to your own work and document that part,
yes.
you actually do
Yeah.
that.
There are total 246.75 lakh registered and unregistered small setups. So in this research work, they focus on computational fluid dynamics, mixed-mode ventilation, and natural ventilation. So basically, computational fluid dynamics is talks about the computational fluid of fluids, be air or water, of any liquids, uh, and mixed-mode ventilation talks basically is defined as a combination of mechanical and natural ventilation. And these are the set definitions for these terminologies. The objective of the study was to study and understand natural ventilation in mixed-mode ventilation in the chosen fabricated zone and in a particular office building to establish the various parameters affecting natural ventilation and mixed-mode ventilation. To derive the CFD analysis data, the efficacy of natural ventilation and mixed-mode ventilation is flow rate as the key parameter. And further to conclude with the importance of flow rate as a parameter to achieve thermal comfort to natural ventilation and mixed-mode ventilation. So the methodology which shows was divided into two parts. The first one talked about the theoretical research study, and the second one was based on analytical research. So, theoretical one talked about the basic study and the research, formulating a research question, and doing some literature review. And if there was any lag in data, so we did the work personally and then examining the data doing the analysis of operating performance. The second part, which talks about the analytical research through CFD, talks about these are data collections which are there. So starting with the foundation program and the context that we have to study, then the selection of test cases, the finalize the site for conducting tests, then finalizing parameters for analysis. Under this, then we first did the external COP analysis, then followed by the internal COP analysis. Then, so in this overall process, each and every analysis that we did get the data. So the outcome of one analysis was the input data for the another set of analysis that we had to do. So for building cases for the study, first we identified the climatic zone. So we chose Andover city, and for that particular city, so this graph also shows you the thermal data distribution of rapid comfort zone in our naturally ventilated spaces. So you can see over here, in the winter months, which is October, November, December, January, February, you can see this is too hot, very too hot in the winter months as well, the city. So the model that we proposed for maximum ventilation was seasonal based maximum ventilation system. I guess to talk about incorporating natural ventilation in the winter months so that you can work on the achieving the thermal comfort in that particular period of time. So this was a sketch that SBE did, so I will have to look this long sketch, and these yellow patches that you see are what is selected breadlines which we study for deriving our initial parameters on how what should the test cases work. Then on the basis of the study, the comprehensive breadlines, we finalized that okay, these three were the types of breadlines. And then the second result of the diagrams, which should be carried forward because these were diagrams which were probably seen in the both particular steps. Now we finalizing the site for analysis, so we chose a particular site in that same step only, where we got the same regulations, like after I was there, the same one, so we could get the same measuring height, which so to draw a more comparative analysis. The parameters for analysis, as I mentioned, so first I will talking about the safety parameters. So these are basically the parameters to put in the two kind of simulations. So for external safety analysis, it talks about the site level. And these are the respective parameters that have to be taken care of. Now the outcomes of external safety analysis was spent in the internal CFD analysis, which talks at a building level or at a floor plate level. Followed by the parameter of analytical study for natural and maximum ventilation. So whatever the outcomes got there for internal CFD analysis were fed in for natural ventilation simulations. So that the first CFD analysis is telling me how much wind velocity I have achieved at particular wind, which is at the external level. So what is the wind flow inside it in the next couple of slides. So these were the outcomes of external and internal CFD analysis. So as you can see over there, in this one, the blue ones is the least and towards the red is the maximum wind velocity that we achieve. So this is a particular example of a rectangular flow plate type, and these were the simulation results for a multi-critical peak for a triangular building. So, and this one, you can see there are overlapping graphs, but primarily which I should say that the room temperature which was there, what was there, the speed and the direction which was prominent at a particular day of particular time, a particular day, and followed by maximum ventilation simulations. So these were the results for that. So this again was for the very typically, very typically, which is from 12 November to 18 November, and for our really simulation results. Now, the observation from all these simulations were, this one is particularly for the natural navigation simulations that we did. And we focus at the total pressure that is coming inside the building and the number of hours that a building is, the temperature is not in the on the comfort zone, which is as per the software and as per the actual 55 it says that it's 30 degrees or more. It gets uncomfortable. Although it varies on various parameters. These are the results from our basic calculation summarize ones. So we are going to talk about the total pressure which is coming inside the space, particular space. And so you see, I mean, first we did the external CFD analysis to show up the cycle. Then the internal CFD analysis was conducted for a particular full flow plate. And then when we came to these particular natural and external ventilation simulation, we were talking about this also. This was the scaling down that we had to do. So that's why each and every simulation was important and each and every data was a feeding of the background. So these were the results for the other many technologies like SBE1. These were our results for the ventilation, for automation, for natural ventilation simulations and external ventilation simulations. The results for NCA irregular gravity. The reason I chose this particular slide is irregular as the statement has an irregular facade because it's not a straight line. So it has these irregular facade which draws in another interesting factor and the factor in the way the bed is flowing inside a particular space. So these were the results of it. So now for the conclusions, what we concluded from the study was that the natural ventilation results were more favorable in flow gates with poison irregularity, that is L-shaped buildings. Rate of ventilation in space depends on the number of windows in a particular space, and natural ventilation in space can be improved with the help of variations in flow gate direction. So this is study what the conclusion of the study was fairly basic one, but what we do as we just code that opened up and I was formulating the further research potential of this particular topic. I was so these were the points which can be explored and should be to enhance the potential of the brain documentation simulation or ventilation model in a particular building. So like what are the ratio for natural ventilation, how much is appropriate and the fenestration shape and technologies for natural ventilation and optional building orientation on site for natural ventilation and inputs of optional mechanical systems like VAV in case of study and export simulations. So although there are a lot of variations and a lot of parameters are actually, I mean, the concepts and variables that we need to build in such studies and before executing such models. But this was an overview for the research papers. In the end, I would like to say that buildings do not consume equally. Thank you.
Yeah, now let us answer.
You have not talked anything about how you have calibrated and validated the model, the simulation model.
Calibrated.
How are you validating this model, the simulation model?
Okay. See, what we, I think this the particular building that documented on particular stage. So there are total 5 types of buildings which were there. Okay. So out of those 5, we observe that which are the 3 most, I mean, which are the most prominent ones which are affected. The blockade types. So that was a rectangular building and it shaped building. Although there were variations in that. I'm not saying they had particular proportions, so when I'm talking about like the walls of the shift building, that was not definite, it was vague. But I had to take one particular test case, right?
No, that is actually responding to the typology selection. His question is different. His question was when you are making the simulation done, if I understood the question right, only simulation cannot, we couldn't believe on the simulation results until unless it is very. He is asking your validation process. CIP simulation is giving you some data. You present it in the validation folder.
Alright, so the validation for the literature will be validated. We work a lot of reference for that. So whatever parameters were there that those literatures are, and what are the outcomes of that literature review?
No, we I think if we have not done in the research communication, we have to have that practice. So we have not done it. Validation is not something.
Yeah, of course, alright. Like that, so because that was the process that we have to do. I have to, right? So there was still that lab was there. Now validating the product outcomes for it. But yeah, it's supporting the idea of the overall topic.
I just like to say one thing. See, when you're talking about simulation, okay, you have the actual building and then you have a simulated one. Okay. Now you observe your actual values in the building that you have to measure it outside, and then your simulated values you have to compare. That is the process of validation. Okay, and both of them errors should be very minimal. So here I don't see any on-site measurement of the indoor.
Yeah, because yeah, as I said, there were a lot of parameters that had to be considered, right? So, like for even for mixed mode, if I per se for if I was taking up a study for mixed mode ventilation systems, right? So there have to be certain constants and variables that I have to fix. So, like I said, that I will not go for force occupancy evaluation, which is the primary concern for if you are talking about mixed mode ventilation systems, right? For validating the any particular data that what you're talking about, I shut down the whole process of post occupancy evaluation. I was just talking about the results and
then whatever you are contributing for that, I don't need to go for this. I can put it open beyond me or some other stuff and I can put it out to develop this process, to go for data, internal learning. Basically, it's not to be, it's for all of us. All of us in fact, always that is something that you are actually like any like you not understand how to make it. Four plate is
okay. Yeah, so basically,
last year.
it was there. The thing was that the difference between the technologies that we took, and difference of the external wind fact that the national edition that is the national wind that is moving around. That is to particular geometry, so the different bodies which are there, they are forcing and I mean like they are creating a low pressure and directly go outside the facade only, which is drawing in the natural wind inside the building. Okay, so those are very, I mean like those are the factors which are accelerating the growth, I mean like the natural ventilation or drawing in wind. So that's how the change, the difference in the flow rate was making a difference.
Okay. I think now we will go for the next calculation. But in low rate, in that case, we will discuss about configuration of the flow.
Yeah, that was the final answer.
So after 10 minutes, probably you are supposed to silence.
Good afternoon, everyone. My research is on thermal performance in residential building through building orientation in hot and red liner, particularly context is taken and the work. The aim is to identify the appropriate building orientation options with different building typologies, which can help buildings to get maximum thermal performance. And the result is focus on finding preferable orientation, the facade exposure behavior, and the total fabrication using three parameters, which are type of 2, 3, and 4 pattern hall kitchen residential typology, including window to wall ratio and orientation. The scope of the work is the selection of the simulation software is already suggested by ECDC, and it is taken for the comparative analysis between the orientation and the export person taking care. The weather data is taken from the energy source software, which is uploaded by history. And all the results are based on simulation. Certain standard data are taken from the exhibition and upgrade. Simulation results may vary than the actual results, but actual on-site transfer measures cannot be done due to time limitation. These all are the parameters actually which are participating in the heat gain direct or indirect way. So, in which the site location, the area of the building orientation, building envelope, and the construction materials are responsible for the direct solar heat gain through walls, windows, roofs, floors, and the rate of ventilation, and which are based on its color and its material properties. So these four things are taken as a methodology. First I have done repeatedly to find the proper strategy for the simulation and also for the data collection. The second part I have done primary self studies for the to create a base case model and this base case on the base case model I have done simulation, that is the third part, and the analysis and other. So sampling, for the sampling, 2043 residential schemes, which are mixed typology, like the 2, 3, and 4 mix kind of typologies. This result shows like 58 along from the all 58% of the high-rise buildings are presented. So high-rise typology is taken for the construction of the base case. These all are the findings of area regulation, like 2 BHK regulation, 4 BHK are having average area of 878 to 2,900 square feet of the area. And these are the functional regulations, the average area for each function. It is analyzed from that part. Most importantly, window to wall ratio. Window to wall ratio, it is found like it is used from 20% to 30% and 40 up to 40%. So I have taken 20 to 30% to construct the base model. Then I have done the space planning analysis. So this is the most common space connections found in the all the sampling. And for example, the 2 BHK is generally the two spaces living and dining are attached, and the passage is playing role to attach the two bedrooms and the main kitchen function. So one of the typology is taken for the construction of the base case model. This is such a way for the 3 BHK and 4 BHK is done. So the this is how the base case model is generated. It is on the grid of 10 feet by 10 feet and 10 feet by 5 feet. The base case model is developed, and these are the percentage ratios of the exposed surface for particular floor plate. So 25% is following to north and south, and these 10 west are exposed 80% and this area is 30%. So that's the way three-way information models, basic models are generated. Then the material is applied. For the slate, like these all are the layers which are given to the given as material, and these are the tabulated by the operator. So Q value are taken. It is combined like such a way that Q value is also matched with the ECDC standards. So this is how the slates are constructed, walls are and materials are applied for beds, ceilings and outdoors. The wall simulation is done for two time periods. One is annual. Second is I have found critical time period on the during the analytic part of climate study. So these are the driver temperature, Bible temperature, and the wind speed are overlap for this parameter. And found that the May to July, the chances of the weekends are more as because of higher than the comfort temperature pattern. And also, the psychometric suggests that in these particular time periods, more HVAC and the natural ventilation is required. So, I've done a simulation for May to July as a critical time period. These are the data tabulated, which is taken directly from the utility and input directly in the software. And when I talk about orientation, if I talk zero orientation, 0 degree, then it means lumbar profile is facing north to south, and 30 degrees it is rotated to east. The model simulation is done for several types. There are 72 simulations are done. For example, the 2 PHK typology with 20 WR. So I have done simulation for all these orientation for critical ones and for the end. So there are 72 simulations done, and these are the sets taken for the simulation, like preparing from the base case to the and take the internal light references to the simulations and final report results. So this is a result for 2 BHK typology, which showing heat gain analysis for critical ones. This is how the static gain is working in this particular typology. And it shows like between the 2 to 8, the heat gain is maximum heat gain duration. And then we tabulate in tabular format. So this is the average data received from this calculation. Like for 2 BHK, the zero orientation, 20% oriented, and we have 771 kilowatt hour is the average heat gain is happening. So I have given index accordingly. So the most beneficial typology for this particular critical one is 2 BHK, 30 WR and the 0 degree. That's the way 3 BHK are found. The 30 WR 0 degree is the most advantageous typology, and for 4 BHK it is 30 WR is the 120 degree is the most advantageous typology. Then I have done simulation for manual performance, and this is the tabulation of the result. Like here are the window to lectures, and these are the 2 BHK typology, 3 BHK and 4 BHK typology. And these are the orientation. So I have given index from 1 to 6, which is meaning minimum weekly to maximum weekly along with the orientation and WR. So these are the conclusions. For 2 BHK, we are following 20 window to wall ratio. Then 150 degrees to most beneficiary orientation, and the worst orientation is 60. So you can, I mean, the difference between two is 170 kilowatt hours per square meter. So this is the finding for the 2 BHK. That's where 2 BHK 30 window to wall ratio if you are following, and 0 degree is the most advantageous. So 3 BHK for the 3 BHK 20 WR, 90 degrees is the most advantageous, and 30 WR 60 degrees is the most advantageous. And for 4 BHK 20 or 30 WR, the 0 degree is the most advantageous. So this is the conclusion, and it has a future scope also, like adopting same typology architect and designer can achieve maximum thermal performance in their housing scheme or high-rise design. If site is site is restricted and it cannot give permit to give proper orientation, then I want the critical facade also, and for that facade designer can to design proper site devices. Then all these modules are developed on the basis of green sizes. So designer has various combinations available for using these particular breeds. And also taking some cost advantages typology study can be taken further. Like you can have now third parameter like daylighting, and you can check whether it is working or not. And these results are also helpful for town governments, which are useful for data development. Like they can develop schemes accordingly that it allows advantages business. Yeah, these are the
Question for Bobby. Yes. Question for Bobby. Yes, please. In the conclusion, you suggested the results for the unit, right? And there are two units, beam and power. So the results cannot be similar to both units. Is that your conclusion? The conclusion, the last one. Whether are the diagrams. You know, there are two apartments in the unit. And there is a home, this is a one.
This is the one typology. This is the advantageous typology which design is doing 2 BHK kind of residential typology. And according to design, he is actually 20 kWh. Then the best orientation for that typology is 150 degrees. This is showing actually that orientation for that particular type. This is separate. This is separate. Yeah, the 4 units in one.
Yeah, the guy is taking a 2 units in the same block, so the result must be very different.
No, there are 4 units actually in this. So basically, these are 4 units in one surface. This is the typology which is commonly found. Like if you have 2 BHK, then 46 units are most common in one plate, and if 3 BHK is used, then 4 units in one floor plate, and if 4 BHK is used, then 2 units in one floor plate. This is the common typology I have found. So I will take
It is slightly different in the result and you might be finding. You can say that can be average out the result.
Yeah,
But it must be different for each unit placed on a single plot.
Right.
What she asking, you have 4 units here. So the or you are explaining
Total not so. It is done for entire one block.
full block.
Full block. For the total. This is I'm showing only one floor plate here because of the typology.
I just want to say, you have used actually comfort zone for that study. I saw it right as have you studied NBC, National Building Code?
The NBC and ISRA is like they have already given 27 to 30, but I have taken that software, so I have.
Actually, if you take the temperature limit of 25 to 30, which is what is recommended for naturally ventilated buildings, as per the NBC.
Yeah.
Okay, QSI, that is based on the protocols underneath.
Actually,
So, then the results will be.
no, I got the one and I have taken that also in consideration. Like, if you go back. Yeah, here I have previously said like 32 is the maximum comfort temperature and 27 is the minimum comfort temperature. I have already figured that data and I will change that after from 27 to 32, I'm sorry, 23 to 27, I'm 10 to 27 to 32 in 20 already I have covered.
And what you guys also like again,
Yes, ma'am, that's why I raised the limitation part.
make sure that we can without as you
Otherwise, the simulation software takes on
simulation software we have to understand we are not going to make use of this any time and I will understand that I will not place proper regard with you. Okay, thank you. Next,
Thank you very much. My name is Krishna Mediasika. I'm a professor from Petra University, Indonesia. I'm here to represent my student, Johan Haryono, who's unfortunately cannot come due to some medical reason, to present his research paper. Actually, this is a very simple research paper of an undergraduate student to have his diploma. And the research title is for creative defects and occupants section on indoor temperature of typical student apartments, specifically to Surabaya, Indonesian region, with temperature range between 29 to 32 degrees centigrade throughout the year. It's considered as quite hot to that condition. The background of this research is that the building located in the tropics experience excessive solar radiation throughout the year. As I said, the temperature is between 29 to 32 and to be more than that. Building envelopes, especially the vertical envelopes, walls, doors, windows, etc., play important roles regarding the transfer. Actually, there are a lot of research conducted saying that night cooling is considered significant in lowering the indoor temperature. However, for buildings that are occupied at night time, night cooling seems to be impractical because of the safety reason and the possibility of the insects to go to the interior ambient. Then, the low indoor temperature maintained by its weighting is expected to be the most important features to shorten the use of air conditioners. Why is the use of air conditioner? Because the night cooling is impractical and that the temperature is beyond the comfort. So the occupants must use the air conditioning system, and it depends on the setting, so that the initial time of the air conditioning system will be as effective as it is. Johan wants to conduct this research to guide his colleagues, his friends, in further renting or buying apartments in it by considering the trading tax. because we credit cards are easily to receive to the data. So it doesn't necessarily to be an architecture student or civil engineering student that dealing with the building, but any kind of student can easily consider the trading when they want to rent or buy apartments living this. And the methods that employed here is empirical research method using quantitative methodology. It was an on-site measurement and also completed with questionnaire survey, video conference together the occupancy section on the indoor temperature, whether it is affected by the presence of credit or not. And there were three types of apartments while trading studied here. First is glass window in the east. This is the A apartment with glass window in the east. This is the window and this is the east. This is a very small balcony. And then the second type is a plain wall trading with glass door. This is a plain wall. We have a glass door. This is the balcony. And the third type is window. There is a window on a plain wall with a small balcony and a glass. This is the detail of the planning that we studied. This is A apartment with approximately 4 windows, I think, the small width and horizontal bar. This is apartment B, plain wall, small door in the balcony. There's a window on a plain wall and small door in the balcony. And this is the proportion of the material used in each apartment. This is the apartment, the apartment, and C apartment. You can see here that the apartment are mostly built with compact material, concrete, ceramic, and the apartment consists of the more transparent material. You can see here that the apartment has window to wall ratio 11%, the B is the smallest, and the C is the pretty. The variable that we control, that we log to be able to provide the public comparison between the trading. So we log this kind of variable orientation. All the apartment unit are facing north. The floor, 2 floor height in each unit are approximately 3.5 meters. Floor height above the ground. A little bit different because the apartment C has no 40 meter floors, 60 meter. I think it's not really matter. And the dimension of the unit is 24 square meters. This is a studio unit apartment, so 1 bedroom. The object that we try to test is the building itself and the wall, window to wall finish. This is the training specification. And the on-site measurement were taken using robot as a launcher. It was sent outside to measure the outdoor temperature inside. This is in A apartment, this is in B apartment. You can see there is a balcony, this is in C apartment. So 2 robots this all together. The measurement was conducted consecutively for 3 weeks in each apartment. So we spent quite a lot of time to do the measurement. And altogether with the on-site measurement, questionnaires are very distributed, and this is the demographic condition of the respondent. About 100 questionnaires was distributed and only 81 written, and the proportion between A, B, and C apartment are pretty much the same, it's approximately 30% each. The occupants of the apartment is pretty much the same 50-50 between male and female, and most of the respondents are 26 to 29 years of age, which is the age of an undergraduate and postgraduate student that occupy the apartment. And the period of occupancy is below 40 years, which is correlated to the period of study for the student. And what Johan found out and discussed with me is that the cladding with larger window to wall ratio, which is apartment A and apartment B provide relatively similar lower delta. Delta is temperature difference between outdoor and indoor. You can see this is apartment A, apartment C, 11% WWR, 8% WWR. The delta is pretty much the same. But in B apartment, which WWR are only 4%, but interesting phenomenon was happened there, where the apartment with plenty of the largest delta, this is the apartment with the largest delta, experienced highest indoor temperature. You can see this. This is the outdoor temperature during the measurement, where it is true that in apartment, outside the apartment, say, the outdoor temperature is slightly higher than the other two. But the indoor temperature in the B apartment, which is have the largest cell now, is the highest among the other. And at night time, the temperature remain the highest. And then finally, we realized that it was caused by the overall material of the apartment B, which is predominantly light consensus long time lag. This time lag is a time required by building material to store and release the heat gain during daytime into the night time. That's why within the apartment, the indoor temperature remains high during this night time. For when we scrutinize the condition of the B apartment, see, this is the B apartment. Actually, the wall belongs to toilet. Now, what happened is that it was during the measurement time, because there is no one occupying the apartment, the toilet door are open. And the heat came released into that room. That's why it is true that this wall influenced the indoor temperature. That's what he found. So this is due to the time and the question arises regarding the available of it, so we can answer as well. And this is the finding of the question that was made. 75% of the respondents found out that when they're entering the room after studying, like that room through the evening, they feel uncomfortable, they feel hot. So that's why they need to turn on the air conditioning. And after they turn on the air conditioning system, 60% of the respondents say that the air conditioning system needs initial times between 10 to 20 minutes, which according to them is too long. Wanting to wait to get the desired enjoyment. Most of them expected that the initial time 10 minutes. But that's not happening because the theory says it will 10 to 20 minutes. And this is the other link between learning on home, learning at school. The conclusion of the study is that creating a large proportion of outdoor material compared to transparent material offer a larger delta of outdoor indoor temperature. However, when the outdoor material has long or large time lag, as in this study, the indoor temperature remains warm the whole evening. The outdoor material ideally has shorter time lag so as not to distribute heat gain during the daytime into the night. In overall, plating type is covered transparent material between these combined with lightweight bricks with short time lag over lowest indoor temperature, and this is more favorable. The
fact that the indoor temperature was still above the ambient room temperature, and whilst 50% respondents believe that wedding has an effect on indoor temperature, the 25% were all not capable of sitting the occupancy while under these three types of building needs to be upgraded to support the consent of local indoor temperature before the use of consent so that can trigger the shorter use of electricity. The study indicates that the use of simple and small companies will do the task of reducing solar heat while using transparent material for cooling. I think that's more like the presentation. For the study on the most effective type of companies to create sufficient temperature difference with small and less or less installed air system is recommended. The longer monitoring period and survey with more massive respondents being conducted to provide stronger justification is also recommended. That's all I'm saying.
The law is get two elections. Celebration.
Not really interesting, probably. So the questions.
What is the ideal indoor temperature for your country as per the codes?
Most of the respondents say that they usually set the air conditioning system minimum 25. That's the desired indoor temperature. The Norwegian government actually suggests to save the energy not to turn on air conditioning system throughout the nation below 25. Some of the students, for example, that were bigger and a little bit fatty body, actually expected that the indoor temperature was 23, 20, something like that. But there is a regulation of our government that it's supposed to be set on 25. But because the outdoor temperature range between 29 to 32 is considered uncomfortable, that's why they turn on the air conditioning during the night time.
Because when we are talking about comfort temperature, right now the adaptive thermal comfort model is gaining a lot of popularity. Okay. And what we do in that is we administer the questionnaires to the occupants and we try to find out the thermal perception of the occupants that what is the ideal indoor temperature that the occupants are perceiving. Okay. On an ISP scale, that is we have 7-point scale. Okay. That is from too cold to too warm. Okay. So those occupants who give maximum number of responses in the 0 scale, that is the neutral scale, that is considered as the ideal indoor temperature. So, I believe that there are a lot of thermal comfort studies that have been conducted in Indonesia on adaptive comfort. How does that, have you considered that aspect of studies, adaptive, using the occupant's perception of the indoor, because it is variable. It will not be one single temperature, it will be a variable temperature. Because what seems comfortable for me may not be comfortable for someone else. Someone else may be comfortable at a much higher temperature. That depends on one's thermal perception. So that's what
I know. That's why that he's not setting the questionnaire survey by asking what kind of temperature that make you comfortable. That's why he switched the question to what degree of centigrade that you set your air conditioning system when you occupy the room. And the answer, actually, some of them want to have lower than 25. But then they remember the government regulation and suggestion that Indonesia are suggested to use 25. That's why most of the respondents set it to 25. And to reach 25, from 32 to 25, the air conditioning system needs about 10 to 20 minutes. That's the focus of the study. So, and the respondents say that it's too long. They wait too long to get the desired indoor temperature. They want it less than 10 minutes. Thank you very much.
Now I would like to listen to Kanika.
Yeah.
Good evening, everyone. I'm going to talk about the cooling laws of the education building, very case-specific research done on the University of Allahabad. To give you a very brief context, I'm going to talk about India has gone to a level of a second education system across the world after China. It is estimated that the 32% of our population is going to require higher education in coming 5 years. So that matter, we will require a lot of resources to put through in the higher education system. Union Academy has suggested to connect a lot of universities and polytechnics and campuses through the technology to share and store the knowledge we share here in the campuses across the different people who are based somewhere out there. My daughter intent, for that matter, we would require sort of special kind of spaces. We call them multimedia spaces, which are going to be a mandate for the education society. So the broader intent of the research was to understand how to reduce the consumption of such spaces and further on to learn the cooling patterns of those spaces. To know more about the multimedia lecture theatres, what they are basically, they are the highly extremely functional spaces with the controlled environment, being integrated with the high energy utilization of the technology and clubbing with lot of systems. To elaborate it more, the systems are the AV systems, IT systems, security, safety, and lot more. To make a point out there, the equipment utilized to make a setup out there to make it work what it's actually intended to. There are cameras, different types of cameras, AV cameras, focus cameras, still cameras, mic, speaker systems, and a lot more to document the way as it is. There are computers, there are tablets being provided to each desk to notify what exactly is going on and to be stored in the same manner. So there are quite the energy being utilized or being heat sort of generate within the environment, which we need to understand for such cases. To give a very quick idea about what very specifically I'm going to talk about the cooling load. Firstly, the total cooling load required is the energy required to negotiate the extra heat from an environment and to maintain a heat balance to create a comfortable environment. If we divide it as per the area of the generation, we can say there is external load and there is internal load. In our particular case, there is a substantial internal load because it is being provided with too many of equipment in the premises. So to sum up the internal load, we can say there are loads from the people, which is being followed the electromagnetic load from the appliances, load from the lighting, which is very specific in our cases because the focus lighting and ambient lighting needs to be controlled in such cases. In the case of external cooling loads, there are loads from the opaque surfaces, there are loads from the translucent and transparent surfaces, such as the glazing and all, and there are loads from the insulation or the ventilation. I have done my whole research has been done on the basis of my energy simulation. For the simulation and to figure out the cooling loads, I have done experimental setup and there are three variables being considered. One out of that is the exposure to the external environment. Why is it so crucial for my particular case study? There is a requirement to understand the exact location of a lecture theatre in respect to the whole complex. First of all, there is this idea of heat gain, and there is also an idea to let the heat dissipate back to the environment. If the heat is being generated within the environment and we are not letting it or not providing enough surfaces to get it back to the environment, it is a problem. So there are two cases being generated on the basis of the reference model of the University of Allahabad. One is having a 30% of exposure in this much of the body, then 50% of it, then the 70% of it. Every variable is with the material assembly. Though they are considered common on average material being used in the market, but the intent is to understand how they work with respect to the insulation. If the insulation is being provided with the wall or on the roof or with the floor, what will actually happen? When we actually control the heat within the environment. And there is this third variable is of the orientation. So in short, these are the total combinations and iterations I have run through for the energy simulation, which sum up to the 120 sets. Every combination is being run for algorithm 1 as well as for algorithm 2. They are being run for all the material types and for all the cardinal directions. These are sort of results I found from the design builder. Design builder is a user interface for the energy plus software that is used as my tool. On the basis of that, there have been sure observation I found out way to move. In the further experiments going to utilize for the multimeter extractor. First of all, there is a substantial load which is being made internally. Let's say that 54.4%, which stretch across over the year with all these. Second of all, if you want to alter the facade with respect to the exposure and the material assembly, at the most, you can only interfere with the 28 to 46% with the cooling load which is being gained from the external. So this is one of the graphs. There are many graphs which actually sum up to my study. This is for the audible and this is for the audible. There is slight difference as per the location of the observations. This is observation 2. It talks about the material applied. The particular case of size B, which is the wall with the insulation but not on the floor, has the maximum impact. So to say that bundle C and bundle P at the peak load J of the air have minimum heat gain from analog in comparison to ADP. It is ranging from 0.5 to 1% reduction in total cooling load. So at max, we can say the type B has minimum cooling load across the air. The possible reason for the difference is the absence of insulation on the wall, hence dissipating the heat load back to the environment. This was my point from the very first starting of the result that there is a bigger possibility that we are controlling the heat within the environment, is not letting the heat go back to the environment. There is this observation on the basis of the orientation, which is a very marginal way. In such cases, when you are designing a controlled environment, even when you change the orientation, there is very little impact because you are generating the heat with it. This is the observation on the basis of wall height and the impact of orientation. So now that we want, this is one of the, there are detailed instances, but I am just focusing on this to take the point out of it. Single 230 and the regular one with wall, the insulation in comparison to without help reducing to 40 to 46% cooling load at the maximum load of the day for all orientations. So the range slightly varies for different model exposure. For 40% reduction is 41 to 46% with the range provided. Similarly, cavity walls with insulation in comparison with cavity walls without insulation have impact reduction of 38 to 41% for all cross orientations. The reduction of 30% wall exposure is similarly being explained here. So the overall conclusion, we are saying that providing insulation that we are helping the building to control the heat. Actually, we are forcing the heat to be within the environment with us. So it is important to understand the location of the heat generated and the placement of the insulation. We are at times not required to place insulation on all the sides. Let them dissipate back to the environment. And to say there are the bigger possibility to take the study further on for all these cases because one day case study which is 10th June, a pink road day at the composite manor of Allahabad because the whole study focuses on a very election based environment of composite manor of Allahabad.
Yeah, please. Audience and questions. Do you have a question? Yeah.
These are the simulation results.
Yes.
Okay, have you tried to compare the base case, the cooling of the base case model with the actual cooling load on the electricity bills?
Actually, the pilot project I have taken is still under construction. It is being proposed several times across the city of Allahabad. So there are several models which is being suggested for coming 5 years. So my intent was to make a point that the initial model you have proposed, if you change a little bit of difference, you might get better results. So there is no physical model provided for me to compare it. That is why I did a lot of iteration to understand better the model designed by an architect.
Basically, a design.
Yes.
We try to simulate and compare them.
Yes. But it's been designed by an architect which is actually being suggested to or being proposed to all universities around us.
It doesn't exist.
It's ongoing process.
Any other question? So, she has elaborated very graphically, maybe ATV.
Thank you so much.
Or that, all of you are from Ahmedabad till now who have posted in this section. Because I was I have been reading a particular marketing and if that what is the interest or where is the interest and if it's a navigation some industry who benefits in the area and who have shown that how we take care of the climate change. So in the blank comparison,
Speaking of, today I will present the impact of solar installation on building analysts in 4 primary zones of India. These are the outlines which will be covered in this presentation. That is introduction, primary introduction, objectives, methodology, I am doing a master's in sustainable architecture from Day-02. Methodology, analysis, simulation results, observations, conclusions, and references. Now, I first briefly summarize my work. I have done a detailed study to evaluate the performance of a building located in cold climate zone of India by using various passive architecture strategies. The methodology and results shall be presented in the next part of the presentation. Now, what is solar passive architecture? An architectural design which takes the benefits of its environment and at the same time minimize the impact of climate on the occupant comfort. Why is solar passive architecture? It's a way of reducing the amount of energy, that is operational energy, and to avoid uncomfortable temperature fluctuations over day and night cycles. And by replacing the heat sources derived from biomass or fossil fuel by using other conventional sources of energy. Now, this is the data of Srinagar. I have selected the Srinagar data, Srinagar city for the analysis. This because it's extremely cold climate of India. The altitude is 1587 meters, latitude is 34, longitude is 74. And in December, January, and February are the months which are extremely cold. June and September are slightly comfortable. July and August are the months where some cooling is required. April, May, and October are the months which can be made comfortable by providing solar certificates. Now, before talking about radiations, we should understand what is solar radiation. Solar radiation is radiant energy emitted by the sun. The component of solar radiation is ultraviolet, light, infrared. When solar radiation falls on a surface, one part of it is reflected to the environment and the other remaining part is absorbed by the surface and converted into the heat energy. Now, this is the average temperature graph of Srinagar. The climate data of Srinagar showing the average temperature of the city. So it can be seen here. It can be seen here that the average temperature of the Srinagar is where we should. I'm sorry. Average temperature of the city. So it can be seen in the chart that the Srinagar is the city where we should welcome the sun and the heat gain in the building. But at the same time, we have to think about the strategy for the month where we need to cut down the solar radiation. And this is the psychometric chart of Srinagar, which shows 370 hours are naturally comfortable range, and 2370 hours can be converted into the comfortable range by providing passive solar heating. This is the that area which can be made comfortable. The main objective of the study is to investigate the influence of solar radiation on the building surfaces and the relationship between building symmetry and orientation and surface volume ratio to the solar insulation, so that the appropriate solar strategies can be explored in the initial stage of the design. And this graph shows a typical solar radiation pattern falling on the vertical and horizontal surfaces of the building in Srinagar. And the figure shows the hourly incident solar radiation for all the months. As you can see, the graph, the bright yellow is the surface which is like the highest intensity of solar radiation, and as it comes to the bluer shade, the intensity goes down. The highest amount of incident solar radiation is available in the summer months, which is May to August. The ecotech is applied to investigate the intensity and distribution pattern of cumulative incident solar radiation on the surfaces on an hourly, daily, and monthly basis. 4 cases have been built in order to simulate the impact of solar radiation towards building form, orientation, and surface volume ratio. This study investigates the impact of solar radiation towards building shape, orientation, and surface volume ratio. Srinagar weather file has been selected for the simulation from the Plus website. These 4 models have been selected. The weather shape and models which I have simulated for evaluation, I'll explain all this first. 4 different building models are developed for simulation analysis for the design case. Each model has 3 different scenarios. This first, second, and third. Each scenario is having design case, base case, and base case 2 with the same surface area. All 3 cases have got the same surface area, only the shape differs. Where design case is a combination of rectangular forms, and the base case 1 is a cube, and the base case 2 is a cylinder. This table depicts model 1 being simulated with the different orientations, north, east, south, and west. And the models are simulated for the different orientations which are having the same surface area. Simulation has been performed to evaluate the incident solar radiation on all surfaces in each orientation. Now, the simulation results for model 1 are discussed here with the help of graphic representation. The x-axis shows the month of a year, and the y-axis shows the incident solar radiation in watts per square meter. The blue color denotes the incident solar radiation falling in all months. Green color denotes the solar radiation for the base case 2, and red color for the base case 1. The base case 1 of a model 1 has the highest amount of solar radiation, followed by base case 2 and design case. This is the north orientation. This is for east, south, and west. The same exercise has been followed for the other models also, model 2, model 3, model 4. And these are the average data, average results for all analysis. The average incident solar radiation of different models for design case, base case 1 and base case 2 are provided here. The blue color represents north orientation, red green and violet represents east, south and west respectively. As you can see here, there is a legend north, east, south and west. As a result, demonstrates that the base case 1 of model 3 is getting highest amount of average solar radiation when compared with all other scenarios. This is model 3, and this is the base case 1, which is getting the highest amount of solar radiation as compared to other models, which is getting below 19 or 2000 kilowatt per hour. Here are the results have been concluded together in one graph, where the x-axis represents all 4 models and y-axis represents the incident solar radiation again in watt per square meters. Further, blue line represents design case radiation. The blue represents the design case results. Base case, the red one is for base case 1 and green one is for base case 2. The results suggested that the incident solar radiation have been the least for design case in 3 models when compared to all other 2 base cases. The table is showing the incremental percentage of 2 base cases over the design case. In the model 1, base case 1 is getting 38% more radiation over the design case. Similarly, base case 2 is getting 18% more radiation over the design case. The same trend has been followed for other models also. For model 1, 2, 3 and model 4. And the results for model 3 shows that the least radiations are received by base case 2, which is a cylinder, followed by design case and base case 1. Here are the observations made on the basis of analysis done. The basic building shape, influence of total solar radiations on the cube building, which is model 3, received 6% more solar radiation than the design case. Orientation, symmetry of the cube building with orientation east, north, west and south, showing that the most critical surface to be protected from overheating is west surface, followed by east, north and south. Conclusion, these are the conclusion made on behalf of the analysis done. The model 3 received maximum solar radiation. Model 3 is getting 19% more solar radiation as compared to other model 1, as compared to model 1, which can be seen in this table. Which can be seen here. The tube form increases 6% of incident solar radiation in the design case. The cylinder form decreases 5% solar radiation over the design case. For model 1, the west orientation receives maximum solar radiation, followed by east, north and south. Model 2, the west orientation receives maximum solar radiation, followed by east, north and south. For model 3 again, the west orientation receives maximum solar radiation, followed by east, south and north. For model 4, the east orientation receives maximum solar radiation, followed by west, south and north. Hence, west surface is getting highest amount of solar radiation, followed by east, south and north. Model 3 is getting the highest incident solar radiation, whereas model 1 is getting the least amount of solar radiation because of passing of the building. So it can be concluded that the model 3 is the best case scenario in Srinagar, which is a standalone rectangular building to gain the maximum heat. Therefore, it can be concluded that the thermal performance optimization of building component plays a very important role in Srinagar climate.
Yeah,
Yeah, so the average use of solar radiation was for the entire year or for a specific period of time?
No, for average,
For the entire year.
yeah, it is an average.
I mean, at certain points of time, solar radiation will be quite useful to have, right? So how is that, you know,
I'm sorry, again.
like solar radiation, depending on the time of the year, it is actually useful to have more solar radiation. So to actually compare it as an average especially in climate where, you know, the requirement. Yeah.
I said now, we have to see whether it is required for that month or not. Accordingly, we have to apply these strategies, like overhangs and all.
No, certain point of time, you need the radiation. So, so your base case, you know,
So
base
basic parameter which is based on that particular parameter as several showed in the study. We should be setting against. I think his question is not for parameter. Whether you really try to avoid the or you wisdom that we
Like only, I showed a slide where I've mentioned the months also. There are only 2 months where overheating is happening in the Srinagar climate.
but it's a building.
Yeah.
You can really change. You try to take the space. That's going to be the overwhelming space. For that, we have certain strategies. If we know that in other seasons, in all of the seasons, there is overwhelming, maybe that strategy is used. But that's going to be for months. So, are you going to compromise for 2 months? Or are you going to
So we can apply other strategies so that
I think that was his question.
I mentioned there that we have to follow other strategies to cut down the solar radiation where it is not required.
Any other questions for her? Okay, thank you, Kadna. Good work. And before we listen to Akhi Mother for a minute or so, I would like to talk to you people, all young researchers, trying to do very good job. But again, I can see there is same trend, and all of you are believing on simulation right, without really going into the details that are these conditions. This molecule can take value. Your location is a very specific location. You need to understand the nature of the problem. Generally, I think first is 1 round of this data feeding is so important. You need to understand whether it is making properly. You need to see whether it is really giving you something which you were expecting. If there is some deviation in the data which you are getting, which actually you expect, then try to inspect what's there. That is the calibration. Calibration. Once my job is done, then you go for validation, at least for 1 to 2 cycles of data. Then you go for validation. Don't try to avoid the established research method. Because all of you, what you are going to do, hopefully, in today's tomorrow's future, you are going to have international audience. And you are going to be accepted by everyone. But if you try to avoid, if you try to go for these shortcuts, things are not going to be accepted even by our design. That is that. But very important now, let's hear. Let's hear how our presentation is proceeding, whether it was relevant to the industrial society. If yes, in which aspects, if not, how to do it. How to change our attitudes. That's very important.
First of all, I have listened to all the presentations very carefully, and my view may be different because most of the people here are very serious academicians, and I am from the practicing field. I would talk one by one. Mr. Mehta's presentation on housing. There was a very serious design competition organized by Reserve Bank of India recently for Jammu, and we got the third prize all over India. and we lost the competition basically because we have not done what Mr. Mehta was advocating. So it is very relevant. So this is one good thing. But Christina's quote is absolutely correct, 100% correct, and I fully agree with it. It is relevant, very much relevant. And she was basically reinforcing what I spoken earlier. Then Mr. Tutorial's floor-based presentation was a bit difficult to understand. I don't know how it can be applied to in the field. I think you should work at how it can be translated in a simpler manner in the field. And Kanika's presentation was also very good, but if I look at from the practicing architect's viewpoint, you should put it in such a manner in the field that it can be applied somewhere in some manner. What you said is agreeable, very good, but Kalpana also, what you said is okay, but the point is that identifying that बहुत होने के लिए जो आप बात कर रहे हो बाकी 10 महीनों में कैसे applicable होगा उसमें थोड़ा कुछ inclusion है. That is the point. Yes. वो कहीं न कहीं थोड़ा उसमें explain करना है थोड़ा. Okay. Then, I was before becoming Prime Minister, Mr. Modi was talking to students at the Ferguson College in Pune. He said that in all academic institutes, he said, I have transformed the lives of Adivasis in Gujarat. He said, all thesis projects or PhD studies I have put together, formed a committee, and I put 3 experts, 2 government officers. I have studied all the models, all theses done in Adivasis. And then final recommendations were made, and those are applied in the field and they work wonderfully. So I think there is a huge gap between what you people are doing and what we are doing in the field. So I would request Dr. Bawa that let's do something to bridge this gap. You are doing excellent work, but it is not reaching us. And I came to CBRI 2 years back. They were issuing some pamphlets, black and white pamphlets, each got a different research and a very similar requirements. And each pamphlet was costing 5 rupees or so. I took all the pamphlets by paying 300 rupees, and I have taken those pamphlets to an editor of a very famous Punjabi newspaper, which has lakhs of circulation. And the editor said that this was a 4-5 rupees or low, and translate them into Punjabi, and let's publish it. And I remember that there was some article research on some thumb rules on septic tanks and something like that. If इतने टर्नओवर होगा तो इतना होगा, इतने होगा तो इतना होगा, इतना साइज होगा. मैंने उसका sketch बना के पंजाबी में लिखी and published it, and I got 100 phone calls from Punjab. So the point I am making is that there's a department that maybe department can write some pamphlets, some articles, but not so much technical. When Rahul read the master plan at Chandigarh, he did it in 4 days. He did it in 4 days. The Chandigarh master plan was prepared in only 4 days. So who will have the clarity to all these simulations and all that? So you create some tips that okay, this is it, do that. So I think this is what is required in the field. Thank you very much.
What we are doing is totally meaningful, but that meaning needs to follow in the proper. With that, I would like to conclude this.
Thank you, Dr. Mohan. Thank you for being a keynote speaker. So now we request our head of department Indra to come and facilitate our session. Thank you, Mohammed. Thank you. Uh, it brings me conclude this and like in another 15 minutes, we'll be starting the next technical session on one on urban design in room 04 and another on architecture and sustainability in 20. There is a key and a right hand. You can see how that Thank you.